Good evening. Welcome back to another week of Meteorology Lab. And while you're looking at these clouds rolling by, let me check my levels here and make sure everything's looking okay, because I've had to do a system restart over the weekend, and sometimes things get a little bit messed up. Anyway, looks like we're looking pretty good there. Anyway, let's head to the special segment for this evening, and give me just a second to find that. It's off to the bottom of my screen here. That's the problem doing this webcast. Got so many windows open. All right, going to start out with an airplane here and talk a little bit about how this relates to weather. Now, usually when you're flying along on these planes, you're not too concerned with where the air is coming from. All you know is that it's always about, 70 to 80 degrees, and it's pretty well ventilated. But here's what goes into the air conditioning systems of these planes. It's pretty big mess, isn't it? This is on a Boeing 737. And the important thing here on this chart is off to the right. You can see there's a ram air. So the airplane gets some of its air by just scooping it up as it moves through the air. The other source is from the engines down here. And these all go through what we call air cycle machines, or AC packs, where you have cooling or heating if necessary. They go into a manifold and then into the airplane itself. So considering that the temperature, well, actually here's a picture of the AC machine on a 737. Looks a little bit different from your central air unit. So how does this relate to flying? Do we have to heat or cool the air? You might think, well, this is a Buffalo SKEW-T for this morning. 30,000 feet is right about that level right there. Okay, so if we look at the temperature lines, they're calibrated over here on the right. So there's the minus 20, minus 30, minus 40 right there. So the temperature at 30,000 feet is going to be about minus 40 Celsius. So you might think, well, maybe you have to heat the air a lot when it comes into the cabin. But keep in mind that the cabin is not pressurized to 30,000 feet. If it was, people would be going into hypoxia and having trouble breathing and panicking. And if you want to go to YouTube, look at some of those hypoxia tests in the Navy and the Air Force. Very interesting there. They have them do tests like dealing cards and saying what's on the card. And it's some really funny stuff when they start losing concentration in that very rarefied air. But cabin pressure is usually set at about 6,000 feet or so, 5 to 6,000, and that's going to be about 850, 860 millibars. So we're artificially pressurizing the plane to this level right here. So that's about 5,000 feet right there. Okay, the outside air, remember it's minus 40. So I'm trying to write with the mouse here. Okay, so minus 40. So when we pressurize that air, it's going to have to follow the dry adiabat. That's a physical constant. The air has to follow this lapse rate as it warms. So by the time we bring it into the cabin, the temperature is 40 degrees Celsius, which is about 104 Fahrenheit. And it can be a whole lot warmer, depending on how warm the atmosphere is. It can be as hot as 130, 140 degrees. So you actually need cooling packs, cooling systems, and they have to be very powerful to be able to cool that kind of heat. Okay, let me take a look at the chat here and just make sure we don't have any problems. I think it's looking pretty good. Got a small crowd here this afternoon. We've got, let me give you something to look at before I take a look at the chat. I'll give you the satellite loop. There's a look at what's happening outside right now. across the south-central U.S. We've got Ryan here and ADW. Ryan is preparing for the start of the week, stormy Florida. Oh yeah, hey, I've got something else new. Let me put this on. There we go. Forgot about the webcam there. Okay, let's see. We got Sue M here, and Ryan is reporting 102 heat index and aggressive storms after 2 p.m. And Ron Chalfant is here from California. We have Burl H, Fun with Tech. Missed me while I was gone. Yeah, I miss everybody. Ryan Toomey's radar is lit up like a Christmas tree around South Florida. David Moore wanting some of that rain. Brett Dean talking about a nor'easter up there. 72 in southern Jersey. Yeah, they've had a whole lot of cold air this month. Fun with Tech saying lots of rain in Amarillo. So much water from the past 2 months in Florida. It's a wonder we haven't floated away. Kevin says, don't forget to like. Yeah, I do appreciate that. Fun with Tech mentioning a loopback. Yeah, I'll have to look into that. There may be something weird going on with the mixer. Yeah, just to show you the program that I have to deal with here. Yeah, that's the mixer, and I haven't quite figured out all of it. So somehow, yeah, the sound comes like in this channel here, and then you hear it on this other channel here, and I have to make sure it's going to the right bus and all this, and that there's no feedback, like sound coming back in that way. So I'll look at that a little bit later and try to figure that out. In some ways, this mixer kind of reminds me of that. So anyway. Cool aviation segment. Lost him when he went to check chat. Reloaded all okay. Do I use GR level 3 or 2? I use GR level 2 most of the time because I like working with a higher resolution, the actual raw base products. Yeah, maybe I can bring that up since we've got weather. Okay, GR level 2 coming up. And as far as tropical systems, we got one out in the Gulf. Actually, that's a probability of formation, probably a little wave moving through there. And another one about halfway across the Atlantic. And there's the areas we're looking for as far as development over the next 5 days. So something could possibly go up off the coast of the Carolinas and just east of Trinidad there. Okay, for weather, let's see where we got weather. We've got squall line in the Amarillo area. So I'll bring that one up. Okay, then we'll look at the weather across the continent. Having to move some windows around. Okay, so there we go. We've kind of lost the Hudson Bay vortex right there. This is a look at the 500 millibar chart. This goes back about 3 or 4 days. You can see at the time we had northwesterly flow. We had upper level height anomalies that were low. And that kind of cleared up, and we've kind of built this troughing or this ridging across the North Plains and the Canadian prairies. So as a result, we're getting some warm weather in the central part of the country. And then, of course, out in the northeast where we have troughing, cooler than normal weather. Surface map right now looking like this, showing that departing northeast U.S. system. And behind it, we have high pressure across the Great Lakes. So we can kind of like trace one isobar to kind of get an idea of the extent of that. So this covers this entire area. And that's driving cold air southward across the northeast U.S. And last night, about 2 in the morning here, we had about a good 15 to 20 knot wind, and that was the front blowing through Texas. So we've got a much different pattern today. And out to the west, we've got one little system going through Alberta and Saskatchewan, and we can see downslope temperatures 90 degrees right there in southern Saskatchewan. And then the tail end of that front probably somewhere across Oregon. Okay, the upper air chart showing that wave there across the Canadian prairies. A little bit of a vortex across the high Arctic, but the jet way up to the north, all the way from British Columbia to just south of Hudson Bay. But we've got a little segment of the jet on the other side from the Midwest down to the Gulf Coast. So storms in this area, anything developing down there, a little stronger than usual. The ridge position, pretty much right here where this high pressure is showing around Abilene to Childress. So we're under this northerly flow, and you saw a little bit of that on the time lapse. And West Texas is getting southerly flow. And there's the 200 millibar chart showing the upper level high located right there over Abilene. And you can see that the flow around those storms is out of the southwest. And there's those storms going up towards Amarillo. Don't really see anything severe on here. The cells, you can see the cores are pretty much right in the center, and we don't see any very strong reflectivity gradients on the inflow side of these storms. And the steering flows you can see out of the southwest, so the storm should head mostly into the eastern panhandle area and possibly Oklahoma. Upper level high at 500 millibars, still over the Abilene area. And then at 700 millibars, this is up at about 10,000 feet, same area. And then at 850 millibars, we see it a little bit different. Now it's over Kansas. And then at 925 millibars, which is about 2,500 feet, it's centered probably on the Great Lakes area right there. So you can see down at the surface, it's more based in the Great Lakes. And as you go towards Texas, it tends to be found right around that area. So it's stacking from low altitudes to high altitudes in this direction. And usually that kind of tilt or stacking stacks toward the warm air. So basically that high pressure is there because of all the very strong heating across Texas. And this time of year it can be due to latent heat release. So the kind of high pressure we have is kind of like this right here. We're talking about a warm core high. That's what we have across the central U.S. And you can see the distance between the height layers is a little bit higher than the layers around it. So this is that very warm air in that core. But down at the surface, there is some very dense air filtering down from the Great Lakes. But that's a very shallow layer, so it doesn't have much of an effect aloft. Okay, let's see, on to, there's a potential temperature chart. We can kind of see the leading edge of the front right there, probably in West Texas, the Pecos River area. I think that could be the edge of the front right there. So you see the northeasterly flow and the potential temperature theta gradients back behind this. And I don't think it really goes any further west than that because the values of potential temperature, they're lower and the winds are out of the south. So we can kind of use this chart to find the fronts in the higher altitudes. And then as far as the central U.S. and the high plains, I think it actually may be banked up against the mountains kind of like this. and then maybe connecting up to that Saskatchewan system. And up there in Alberta, you can see the other front. So I think we're kind of looking maybe at a front like that, and then the cold front leading back into Oregon, like I was saying earlier. So the warmest air by far across Yellowstone and southern Montana, and theta values 47. That's going to be about 116 degrees Fahrenheit. If you dug a hole all the way to sea level in one of those mines there in Montana, your temperature would be about 110 down at the bottom, not counting the lithostatic temperature from the rock pressure. All right. There's the storm anvils, and you can see that they are spreading to the northeast with that upper level flow, and the upper level high probably around Dallas at this time. And there's a look at the water vapor imagery, and you can see the very dry air in the wake of that northeast U.S. system. And that's located off the coast, probably right in this area. You can see that S shape. So that's probably indicating a wave in that area. So I would probably be looking at a front something like this. And then back behind it, you can see the very warm air, or very dry air. And maybe you can see that on the SKEW-Ts. Let's see if I can find that. Yeah, I'll bring up the Atlanta SKEW-T. And wow, look at that dry air. Good grief. So there is a little bit of moisture and humidity in the lower levels. We have a dew point of about 60 there at Atlanta, and it's reasonably deep. It extends up to maybe 6,000 or 7,000 feet, and above that, just clear and blue up there. So if you were flying a plane in that area, you'd probably have some very good visibilities. When you do have humidity up there, you tend to have a lot of when you have like a lot of hygroscopic particles in the air, like sulfur dioxide, dust and stuff like that. Any humidity that's like above 50 or 60%, that'll cause that to condense, and it will cause a haze in the atmosphere. So you're probably seeing shots in the tropics where you have that very hazy look, and that's usually due to the presence of a lot of those particles, plus the very high humidity. But clear as a bell right there in Atlanta with that dry air. Here's a quick look at the vorticity. There's the current chart. And we're seeing the 500 millibar high pretty much, I guess, right over Abilene. And there's that river of air coming from the northwest. And here comes a wave out of South Dakota. Now, if we have enough moisture coming back up in this easterly flow with a wave coming through a loft, that's usually a good pattern for northwest flow thunderstorms. Now, in this case, I think it may be too dry for that, but a little bit more flow with these waves aloft and a little bit more moisture coming north, and that would be a very good northwest flow pattern. All right, so we can head into the forecast and we'll look at the mesoscale models. So there's those storms out in West Texas. It looks like maybe the models don't have too good of a handle on this. As you can see right now, storms almost all the way to Amarillo. And they're stretching from about Clayton down to Lubbock. And what the models have right now, it's got, basically the storm right now is located something like this. So the models are lagging a little bit in those details. So that's an area where you would have to be careful. But as far as the north and south extent, that's probably fairly good. So with that in mind, we can kind of see what the general trend is, and you can see most of the development focusing where we have the strong upslope there in the Oklahoma Panhandle, and it looks like stuff south of I-40 kind of dies out around midnight. And there's those fragments making it into Oklahoma by morning, but not much for Texas right now. Okay, so we'll head into the GFS forecast. Well, for some reason I've got NAM, but we'll take a look at that. We're looking at moisture depth here. This is 850 millibars. This is 5,000 feet. Very useful for this time of year because this gives you a sense of how deep the boundary layer is and how deep the good moisture is. So you can see the best moisture from about Houston up to Amarillo. And then over the next few days, you can see that kind of pushes into West Texas and New Mexico. Looks like maybe another shot of moisture coming in for Tuesday. So it looks like most of the better moisture just confined to Texas and maybe Colorado, and not so much in the eastern U.S. or the northern U.S. Oh yeah, we'll take a look at precipitable water. Okay, there's the pattern we have right now. We've got 2-inch precipitable water over central Texas. And this is looking at the atmosphere more through a column through the entire troposphere. So it looks like a lot of that northerly flow definitely pushing the moisture southward to the coast. There's another shot of dry air coming southward. There's that high pressure area. This is going to be on Friday. So that's a pretty good push of cool air. And then for the weekend, looks like that front stalls out between like Atlanta and maybe south of Dallas. Some of the evapotranspiration taking effect here in the central U.S. and adding moisture back into the atmosphere. So it looks like Texas will stay humid, and then by Tuesday next week, here comes another slug of 2-inch air coming northward. And we can also take a look at this in terms of anomaly. This is whether it's drier or moister than normal. And you can see the dry air right there over the Carolinas and Georgia, and the high humidities over West Texas. And then just running this forward, the moisture tries to kind of work northward, and then here comes the next front on Thursday. And then by Friday, pushing southward, and then stalling out right there in Texas. So that could be another boundary that storms have to work with later in the week. Okay, so we'll look at the forecast using the GFS, and let me take one more look in the chat here. Lots of buffering. Good grief. I'm trying to think what here could be using bandwidth. This could be from GR level 2, so I'm going to go ahead and cut that since we're not using that right now. And if this continues, I will run some tests tonight and see what's going on. So let me know how things are looking. It looks like the stream health, it's looking okay there, so we're not losing viewers. I think things are probably holding up. And I'm really hoping we get a few more Patreon donations, because that, of course, means that we will be able to bring in that symmetric DSL and maybe fix these issues and go to some HD 720p. 105 at Canyon Lake from Ancient Astronaut. Jumping Flash says hello. Mike Estwick agrees with the frontal location. Been showery all day. Ryan Toomey's seeing a little bit of buffering, and again, that could be on my end. Upload speed slow. Maybe I'll drop the webcam and see what's going on. Okay. So now the frame is still, so We'll see if that resolves itself. Anyway, I will definitely run some tests. You guys are now saying it's smooth. And it is stabilized. Okay, that's good. All right, back to weather. There's the high pressure across the Midwest for today. Actually, let me run this back. Yeah, there's the high pressure across the northern U.S. Lots of cold air advection into the southern U.S. And the front located all the way down in the Gulf. So there's a little bit of easterly flow and upslope storms right here in the high plains. Okay, so for the week ahead, we just see high pressure across Ohio, Pennsylvania, West Virginia. Looks like maybe stationary front through the Gulf Coast right here. And then we get chances of storms springing up around Thursday or Friday with that good moisture starting to come northward. Here comes another boundary coming southward. There's the front. This is Friday, driven by this high, which pretty much covers all of this area here. This is a good shot of polar air. So there goes the high, moving into the Mississippi Valley on Sunday. Texas in this easterly flow, and easterly flow in Texas is always kind of a humid, cool pattern. And it doesn't take much to get storms developing in that kind of regime. So pretty much high pressure all the way through the beginning of next week, the 8th and 9th. And then we have another system coming southward on the 11th and 12th. And I did want to start looking ahead at the eclipse weather, and we can do that with the CFS model. Now, the details are not going to be very accurate, I don't think. However, we can probably get a look at the long wave pattern and get that reasonably in the ballpark. So what I'm going to do is I'm going to bring this out to the continental scale. Now I'm telling you, this could be killing the internet connection a little bit, so let's see here. Let me see if I can just bring up one product at a time here. This might keep things from getting killed too much. Okay, let's see. 420. Let's see here. 48 plus 44. That's going to be 492. I'm kind of doing things manually here, getting it one frame at a time. Okay, we're almost there. We're looking at the eclipse weather. And let me get this just a little bit further. Okay, that's going to be the morning of the eclipse. And I am working on a study. Let me pull this up here. I've been working, there's going to be a feature here that's going to pop up in the next day or two that shows the expected eclipse conditions, and I've been looking at weather over the past 20 years, and I'm going to kind of show you this in a special feature when this comes out. But I kind of looked at the past 20 years to look for potential problems, and the general thing that I found is the best chances of good weather are going to be pretty much in the Central Plains. The main problem areas could be Tennessee, Kentucky, the Western Carolinas area, and possibly coastal Oregon, maybe to Portland. Those are the areas I would be most concerned about for viewing conditions on the 21st. And you can see the model here still going with a very progressive pattern. Kind of a high amplitude pattern here. So it looks like the jet looks like maybe one segment all the way up to the Northwest Territories, kind of like that. Kind of a light flow through this area. It looks like a little bit of troughing here in the upper levels associated with this high pressure at the surface. So this is kind of a baroclinic high right there. So what I'm looking at here, with a southerly flow here, warm air advection pattern, this would be indicating possible problems in the Midwest area, the western Midwest, Iowa, Kansas City, and Omaha. And there might be better viewing conditions out to the west. That's what I would be looking at based solely on this. And with this trough right off the coast here and the southerly flow, that could be a problem there for Oregon. Southwesterly flow with a trough nearby, that can bring in a lot of cirrus and altocumulus and layers like that through this area here. So just, like I said, based on this, best chances probably in this region right here, and maybe the Carolinas where we have this dry, cool air mass. So that's the first glance here at the 21st based on the CFS model, and this is a 528-hour forecast, so a lot could change between now and then. Okay, let's see, that's probably about all I got. Let me bring up the music here. And one last look at chat. Fun with Tech says we need more donors so we can get a faster network link. Yeah, there's been no Patreon donations in the past month or month and a half. There was a very good outpouring in April and May, but things have slowed down, and part of the problem is due to the summer being very slow, and there just hasn't been much weather. Probably when we get into hurricane season, things should pick up here pretty rapidly for the channel. And if we get an influx of money, then I can put that towards the symmetric DSL costs. Blue skies in Indiana from Sue M. 95% eclipse there on the 21st. Sagan's Run 106 yesterday in DeWitt County. Watching on the Droid Matrix there. Brett Dean asking to see the Smithville EF5 tornado. Yeah, that's a good idea for a special feature. And Sagan's Run waiting for the next eclipse. And yeah, we will get a little bit of a show in the southern U.S. and the northern U.S. It is going to be about 75 to 85% in these areas. So I wouldn't totally rule out good viewing. And then the eclipse itself will be taking a track kind of like that right there. So anyway, that's something to look forward to. Anyway, thanks for watching the webcast, and we will see you tomorrow. And I was going to give you an outside view, but I think I'll do that at the end. Anyway, take care, and we'll see you later.